Next, another one is aromatic, non-aromatic, and aromatic compounds. Anti-aromatic compounds. Aromatic, non-aromatic, anti-aromatic compounds. What is an aromatic compound, non-aromatic compound, and anti-aromatic compounds? See, it is in aromatic compounds. If it is an aromatic, cyclic system is there. Cyclic system is compulsory. Cyclic with continuous conjugation, continuous pi conjugation. Cyclic with continuous pi conjugation. Continuous pi conjugation. Cyclic with continuous pi conjugation. And every ring atom, in that cyclic ring, every ring atom has to be unhybridized. Every ring atom has to be unhybridized p atomic orbital. Unhybridized p atomic orbital. Unhybridized p atomic orbital. So if it is SAI, which means that sp2 or sp hybridization may be there. sp2 is there, one atomic p orbital is unhybridized. sp is there, two atomic orbitals are p atomic orbitals are unhybridized. If it is sp3, there is no p orbital unhybridized. So like that, every ring atom has to be unhybridized p atomic orbital, and the continuous overlapping of the p orbital, it may be also there required. Continuous overlapping of p atomic orbitals. Continuous overlapping of p atomic orbitals. Continuous overlapping of p orbitals, it may be necessary in that ring position. Cyclic with continuous pi conjugation. Continuous conjugation is required. And every ring atom must be sp2 or sp hybridized. sp2 or sp hybridization is there. sp2 or sp hybridized. When it is sp2 or sp hybridization, it may be there, then only that compound which is having the planar molecules. This is important one, planar. Planarity is there, and sp2 and sp hybridized carbon, it may be there. Every the ring atoms may be having sp2 or sp hybridized. The carbon atoms are sp2 or sp hybridized, and planarity of the cyclic system. Planar means planarity of cyclic system. Planarity of cyclic system, planar, which is having sp2 or sp hybridization, it may be there. Right. And the very important one, when the compound, it may be said, when a particular molecule, cyclic molecule, we can say that it is an aromatic compound, follows 4n plus 2 pi electron, 4n plus 2 pi Hakel rule. 4n plus 2 pi electron rule is followed. 4n plus 2 pi Hakel rule. This rule is called as Hakel rule. 4n plus 2 pi Hakel rule is followed. 4n plus 2 pi electron rule is followed. 4n plus 2 pi electron rule, when n is integer, that it may be 0, 1, 2, 3 up to dash, it may be there. 0, 1, 2, 3 up to dash, it may be there. Right. When n value is 0, that is having 2 pi electron. When n value is 1, 4 pi electron. 6 electron. When n value is 2, 10 pi electrons, it may be there, like that. I can explain like that. And if it is a compound is aromatic, due to the continuous delocalization of the pi system, due to continuous delocalization, it may be there. Continuous delocalization of pi electron system. Due to the continuous delocalization of the pi electron system, it will decreases the energy of the pi electron system. It will decreases the energy of the pi electron system. Hence, that compound will be stable. That's why the aromatic compounds will be stable due to the continuous delocalization of the pi electron system. Decreases the energy due to the continuous delocalization of pi electrons, decreases the energy of the system. Then hence that compound will be stable. That means aromatic compounds will be stable. Now, what is that? Anti-aromatic. Anti-aromatic compounds are what? Anti-aromatic compounds nature is what? Aromatic is like this. Similar to the aromatic, anti-aromatic also it may be cyclic and continuous pi conjugation. Continuous pi conjugation is it may be necessary. Continuous pi conjugation is necessary and cyclic system. And similar like this, every ring atom has to be unhybridized p atomic orbital. Every ring atom has to be unhybridized p atomic orbital. Unhybridized p orbital. The second one is also similar like this. The third one is also similar like this, continuous overlapping of p orbital. Continuous overlapping of p orbital, it may be same. And ring atom must be sp2 sp hybridized. This is also same, sp2 or sp hybridized, or sp2 and sp both will be also there. sp2 or sp hybridized, or sp2 and sp hybridized, it may be there. And planarity of the cyclic system is also, it may be same. Planarity of cyclic system, it may be also same. Planarity is also there. And when it is these 2 points follows, instead of 4n plus 2 pi electron system, follows Haeckel 4n pi electron rule. Follows these anti-aromatic compounds are follows 4n pi electron, Haeckel 4n pi electron rule. 4n pi electron rule. When n value is 1, 2, 3 up to dash, it may be there. When n value is 1, 4 pi electron. When n value is 2, 8 pi electron. N value is 3, 12 pi electron. 12 pi electron. And due to the continuous delocalization of pi electron in case of aromatic systems, decrease the energy of the system, it is stable. Now, in case of anti-aromatic system, due to the continuous delocalization of pi electron system, enhances the energy of the pi electron system. It will enhances the energy of the pi electron system. Hence, that compound will be unstable. That means the anti-aromatic compounds are unstable. Now another one, it may be the non-aromatic compound. It is having non-aromatic. Cyclic, but continuous pi conjugation is not possible. That means non-continuous conjugation. Non-continuous conjugation is not there. Conjugation is breaker. Non-continuous pi conjugation. That means the every ring atom is having will be unhybridized p atomic orbital, but here it is Unhybridized p atomic orbital is not there. And continuous overlapping is also, it may be not possible some of the cases. And here it is sp3, the ring atom, it may be ring atoms, maybe sp3 hybridized carbon is there. sp3 hybridization, it may be there. The ring atom is sp3 hybridization, it may be there. Saturation position, it may be there. Saturated position, unsaturation is not there. That is having indicate continuous pi conjugation is not possible. So non-conjugation of non-continuous pi conjugation when it is non-aromatic system. That means ring atom, in addition to the sp to sp, sp3 hybridization is also possible. sp3 hybrid, not all are sp3. Ring atoms may be sp3 hybridized carbonate may be there. In addition to the sp to sp, sp3 is also, it may be there. Right? And here it is, anti-aromatic and aromatic compounds are planar compounds. Planarity is maintained due to the sp to sp. But here it is sp3 hybridized carbonate may be there, that it may be having non-planar. Non-planar. The compounds are having non-planar. Non-aromatic compounds are non-planar. Every non-planar is non-aromatic. Every non-planar is non-aromatic. Not anti-aromatic, not aromatic. Every non-planar is non-aromatic. That means sp3 carbon, if it is there, that it may be having non-aromatic. Right? So here it is, there is no specific rule. 4n plus 2 pi, here it is aromatic and anti-aromatic 4n pi. Here it is not mentioned any specific rule of the system. Right? So because here it is, there is no continuous conjugation is not there. So continuous overlapping of p orbital is also not takes place. Here it is no delocalization of pi electron system. Here it is delocalization of pi electron system is decreases the energy. Here enhances the energy. But here it is, there is no delocalization of, continuous delocalization of pi electron system is not there. There is no continuous delocalization of pi electron system. Continuous delocalization of pi electron system is not there. That is having non-aromatic compounds. Non-aromatic compounds. Right? So this is the aromatic, anti-aromatic and non-aromatic compounds. So if it is, which one is more stable? Which one the compounds are generally more stable? Right? And the aromatic compounds are more stable. Which compounds are more stable? Aromatic compounds are more stable than non-aromatic, then non-aromatic, then anti-aromatic. Non-aromatic is more stable than anti-aromatic. So another one compounds is also there, homoaromatic is also there. Homoaromatic compounds, I can explain which one is homoaromatic. Aromatic compounds are more stable. After that, homoaromatic. Then non-aromatic compounds. Non-aromatic compounds are more stable than anti-aromatic. That means anti-aromatic compounds are least stable compared to the non-aromatic compounds. Which one is more stable? Aromatic compounds. Homoaromaticity is also there, that it is having later homoaromaticity is also proposed. So one sp3 hybridized carbon is there, that is placed towards a bridge position, and continuous pi conjugation, if it is continuous, some of the studies will reveal that even though we can suppose that it may be having non-aromatic, some of the compounds, that is experimentally it is aromatic due to that homoaromaticity. Later I can explain which type of compounds will be there, some specific group of compounds. So aromatic, homoaromatic, non-aromatic and anti-aromatic, it may be there. So aromatic, we know that 4n plus 2 Hakel, 4n plus 2 pi electron rule is followed. When n value is 0, what will happen? That system is having 2 pi electron system, and 2 pi electrons are there, that is having which one? That is having aromatic. In addition to that, fulfill of the aromaticity conditions. Not only the 2 electrons are requirement, in addition to that, 2 pi electrons, cyclic continuous pi conjugation it is required, and planarity of the system it may be required, sp to sp hybridizer it may be must and should, delocalization of pi electron system, like that. That it may be important. When n is equal to 1, which is having n value is 1, what will happen? 4 into 1 is 4 plus 2, that is having 6 pi electron system. When n value is 2, that is having 4 into 2 8 plus 2, that means 10 pi electron system. When n value is 3, what is happening? 14 pi electron system. 4 difference it may be there. N value is 4, that is having 18 pi electron system, like that. These systems will be there, so on it may be there. When anti-aromatic compounds will be there, the compound is having anti-aromatic, 4 and pi electron rule is followed. When n value if it is 1, what will be happen? That is having 4 pi electron system. When 4 pi electron system is there and then fulfilling that planarity of the ring system and continuous pi conjugation is there, it is cyclic, then it may be having anti-aromatic. When n value is 2, that is having which one? That is having 8 pi electron system. When n value is 3, that is having 12 pi electron system. When n value is 4, 4 into 4, that is having 16 pi electron system, like that. 16 pi electron, 12, 8, 4 if it is there, that is having anti-aromatic. Some exceptions also there. Even though if it is 16 pi electron, some of the compounds will be aromatic. What will be happen? Due to which concept? Due to which conditions that it may be aromatic, I can explain based on that example. Initially, we can say that 4n pi electron rule is followed, Haeckel, that is having anti-aromatic, and 4n plus 2 pi electron Haeckel rule if it is followed, that is having aromatic compounds. Non-aromatic, there is no specific rule it may be there. If it is not follows, that is having non-aromatic. Though non-aromatic is more stable than anti-aromatic compound, you remember that. Suppose you know that benzene, how many pi electron system? Pi electrons are there. So you count that the one double bond if it is 2 pi electrons. Even though one triple bond it may be there, triple bond, that is also you count that 2 pi electrons in this particular point of view. Counting the 4n pi electron Haeckel rule point of view, or 4n pi or 4n plus 2 pi point of view. So one lone pair if it is there, one lone pair if it is there, that is having equal to the 2 pi electron. 2 pi electron. That lone pair, if it is participated in the conjugation, if it is involved in the conjugation, then only you have to count that lone pair is equal to 2 pi electron. That is Haeckel lone pair. Participated in the conjugation means that is Haeckel lone pair. That lone pair is Haeckel lone pair. If it is non-Haeckel lone pair, if it is not participated in the bonding. Though it is triple bond, double bond, if it is not participated in that continuous delocalization, that is non-Haeckel double bond. If it is participated in the continuous pi conjugation, that is Haeckel double bond. Similar like this lone pair. If it is not participated in the conjugation, that is non-Haeckel lone pair, you cannot consider that lone pair. If it is participated in the conjugation, then only that 2 pi electrons will be considered for the lone pair of electron. Here, for this system, 3 double bonds are there. How many pi electrons? 6 pi electrons are there. And continuous pi conjugation is there. Every ring atom has to be sp2 hybridizer, it may be there. sp2 hybridization, it may be there. And planarity of the system is there. sp2 sp hybridizer, planarity of the system, it may be there. So 6 pi electrons are there. This is aromatic. 6 pi electrons are there. That means 6 pi electrons are followed, 4n plus 2 pi electron system. This system 6 pi electrons are there. Aromatic. If it is cyclic continuous pi conjugation system, it may be there. Every ring atom has to be unhybridized p atomic orbital and continuous overlapping of the p atomic orbitals. And sp2 sp hybridizations, it may be there only. sp2 hybridization, all are sp2 hybridization, it may be there. Planarity, it may be there. But due to that, how many pi electrons will be there? 4 pi electrons will be there. 4 pi electrons, 2 pi bonds will be there, 4 pi electrons, 4 pi electrons. When 4 pi electrons are there, that is having which one? Anti-aromatic 4n plus pi electron rule. It is follows which rule? 4n pi electron rule is followed. 6 pi electrons are there, which rule is followed? 4n plus 2 pi electron rule is followed. This rule is followed, that it is having which one? Anti-aromatic. That is having anti-aromatic. Right? Suppose which indicates here this positive charge, it may be there, that is an indication of the sp2 hybridization, it may be there, sp2 hybridization, which is there, sp2 hybridization. So cyclic sp2 hybridization, it may be there, pi conjugation, it may be there, conjugation it is there, right? So this bond electrons are shifted to this position is positive charge, it may be there, like this. If it is going to be X plus, this position is positive charge, it may be there, right? So how many pi electrons will be there? 2 pi electrons will be there. 2 pi electrons. This is having which one, it may be there? Aromatic or anti-aromatic. 2 pi electrons are there, which is follows 4n plus 2 pi electron rule. It is aromatic. It is aromatic. Suppose here what will be happen? It is aromatic or anti-aromatic. So here it is 2 pi electrons, here it is 2 pi electrons, only 4 pi electrons are there. 4 pi electrons are there. 4 pi electrons only there. This is positive charge is sp2 hybridized carbon, it may be there, right? And 4 pi electrons which is there, that is having the which one? Anti-aromatic. Though it is sp2 hybridized planar compound, but here it is having 4 pi electrons will be there. 4n pi electron rule is follows. So that's why this is which one? Anti-aromatic. Anti-aromatic. If it is like this, what will be happen? Continuous pi conjugation is there. This negative charge also you may be indicates like this, 2 electrons. Like this it may be there. It may be same that. So here it is, this negative charge is also indicates like that 2 pi electrons. Positive charge is there is no electron. Here it is indicates 2 pi electrons. Here this is 2 pi electrons, here it is 2 pi electrons. Total is how many electrons are there? 4 pi electrons will be there. 4 pi electrons will be there. That is having which one it may be there? Anti-aromatic. Anti-aromatic. Similar like this. If it is having which one it may be there? 2 pi electrons, one double bond is equal to 2 pi electrons. And here it is negative charge also indicates 2 pi electrons. So total how many electrons? 6 pi electrons. 6 pi electrons. This is having which one it may be there? Aromatic. Which is follows 4n plus 2 pi electron system. 6 electrons are there here in this system. Right? It is aromatic. Suppose tropylium cation. Tropylium cation. 787 member ring it may be there. Cycloheptatrinyl cation. Tropylium or cycloheptatrinyl cation. 7 carbon. So this is also sp2 hybridized carbon. Cycloheptatrinyl cation or tropylium cation. So how many pi electrons will be there? 6 pi electrons will be there. 6 pi electrons will be there. Due to that 6 pi electrons, this is having which one it may be there? This is having aromatic. This is having aromatic. If it is negative charge it may be there. Cycloheptatrinyl anion. Right? So 2 pi electrons, 2 pi electrons, 2 pi electrons, this is also 2 pi electrons. With continuous pi conjugation it may be there. There is no sp3 carbon. So how many it may be there? 8 pi electrons will be there. When it is 8 pi electrons means 8 is there in the 4n pi anti-aromatic 4n pi rule, Becquerel rule. So that's why this is follows 4n pi electron rule. So that's why this is which one it may be there? Anti-aromatic. This is having anti-aromatic. Right, like this. So many number of examples I have given. Right, which one is aromatic, which one is anti-aromatic. Cyclic with pi continuous pi conjugation. Cyclic with pi continuous pi conjugation it may be there. That is having. So 2 pi electrons, 6 pi electrons, 10. Sorry, yes, 10, 14, 18 like this, aromatic. 4, 8, 12, 16, that is having anti-aromatic 4n pi rule. 4n pi electron rule compounds. If it is this is what pyrrole, you know that. This is what furan, you know that. This is what thiophene, you know that. Furan, thiophene, and suppose the benzene and pyridine. Now here in this case, this is aromatic or not. When this is lone pair of electrons will be there, this lone pair of electrons are, if it is involved in the continuous pi conjugation, that it is having, you count that for lone pair also it is equal to the 2 pi electron. So this is involved in the continuous pi conjugation like this. So here it is the lone pair electrons also, it may be considered as 2 pi electrons. So how many pi electrons which is there? 6 pi electrons. 4n plus 2 pi electron rule is followed. N is equal to 1, 6 pi electrons are there. So then this is having which one it may be there? Aromatic. This is also. Here 2 lone pair of electrons are there, but only one lone pair of electrons are participated in the bonding. Instead of 2, you have to count only one lone pair of electron. Only one will be you have to count, right? So because only one will be participated in the delocalization, continuous pi conjugation, right? Another one is not there. So that's why instead of 2 lone pairs, you have to consider as 1 lone pair is equal to the 2 electron. Only which one you have to consider? Only 1 lone pair. And here 1 double bond, 2 pi electrons. So total here it is 6 pi electrons. 1 lone pair of electron. So it is also having aromatic. Thiophene similar like this, it is also aromatic. Here benzene is also aromatic. I already mentioned that 6 pi electrons, continuous pi conjugation like this mentioned. And here this lone pair is there, but this lone pair is not involved in the bonding. This is non-Haeckel lone pair. Non-Haeckel lone pair, which is not involved in the bond conjugation. If it is not involved in the conjugation, so you don't count this lone pair of electrons is equal to 2 electron, you don't count. So you can ignore, though it is lone pair, you can ignore that. You don't count that 2 pi electrons. So how many is there? 3 double bonds are there, that it is having 6 pi electrons. This lone pair is not considered, not involved in the conjugation. So how many electrons? 6 pi electrons, 4n plus 2 pi electron rule is followed. So this is having which one? Aromatic. Aromatic. The strength of aromaticity is also, it depends upon the resonance energy. Aromaticity depends upon the resonance energy. Resonance energy. It depends upon that aromaticity and resonance energy, the stability of the compound will be there. stability of the compound will be there. Resonance energy and aromaticity and stability is directly proportional to its potential energy. Like that in the earlier one I mentioned that potential energy. If it is more, that is unstable. If it is less, it is stable, like that. So resonance energy, if it is more, that is having more aromatic, more stability. Right? So if it is the resonance energy of this pyrrole, it is 21. It is 21, right? If it is furan is there, that is having resonance energy is 16 kilocalorie per mole. So 21 kilocalorie per mole, 16 kilocalorie per mole. Thiophene is resonance energy is 29 kilocalorie per mole. Benzene, you know that 36 kilocalorie per mole resonance energy, and pyridine is resonance energy is 32 kilocalorie per mole. 32 kilocalorie per mole. So which one is more aromatic? Benzene, then pyridine, because resonance energy is more, then thiophene, then pyrrole, then furan. Right? So why it is thiophene? Which less electronegative. Less electronegative sulfur atom is there, it is readily involved in the conjugation. Here nitrogen is also readily involved in the conjugation, somewhat compared to the oxygen, here it is less electronegative. Here the oxygen is more electronegative. Right? It's retains, try to retain that the lone pair of electrons, so that's why here it is less resonance energy will be there. Right? Aromaticity, resonance energy and stability. Right? All it is having aromatic. It is having aromatic. If it is and cyclooctatetraene, cyclooctatetraene, cyclooctatetraene. This cyclooctatetraene, here continuous pi conjugation is there. Continuous pi conjugation is there. How many electrons will be there? 8 pi electrons will be there. Generally 8 pi electrons are there. Which rule is followed? 4n pi electron rule. If it is 4n pi electron rule is followed, this is having anti-aromatic. But experimentally, this compound is non-aromatic. This is having non-aromatic, not this. This is having non-aromatic. Cyclooctatetraene is non-aromatic. Instead of anti-aromatic, non-aromatic. Why? Because it is non-aromatic. It's explained its proton NMR structure of its proton NMR structure reveals that. So this cyclooctatetraene is non-planar compound due to its non-planarity of the system. So though it is sp2 hybridized carbon, how it is non-planar it may be there, that it is explained by its tube-shaped structure. Tube-shaped structure. Due to its tube-shaped structure, here it is maintained, some of the strains will be there, due to that it is going to be non-planar. It is having non-planar, then it is non-planar, every non-planar is non-aromatic. Every non-planar is non-aromatic. So this is a non-aromatic compound. Instead of anti-aromatic, it is having non-aromatic. Non-aromatic. It's tube-shaped structure. That can be arranged. It's tube-shaped. It's tube-shaped structure, which is having non-planar. So this is having some of the exemptions will be there. So instead of anti-aromatic, it is having non-aromatic compound. Non-aromatic compound. Right. And some of them examples. Next another one is the homoaromaticity. Homoaromaticity is a special case of aromaticity. What is happening in the homoaromaticity? Some of the compounds, when it is Though it is non-aromatic compounds, but experimentally some of the compounds which is an aromatic due to that homoaromaticity. This homoaromaticity is a special case of aromaticity. The conjugation is interrupted. Conjugation is interrupted. Conjugation is interrupted. Distracted. Conjugation is interrupted. Disturbed. Conjugation is interrupted by a single sp3 carbon. Single sp3 carbon. So conjugation is interrupted by the sp3 carbon. Though if it is depending upon the molecule sp3, single sp3 carbon or more than one sp3 carbon also it may be there. One or more than one sp3 carbons which is conjugation is interrupted. So when this conjugation is interrupted by the sp3 carbon, then this sp3 carbon, whatever that it is interrupted, that will be placed. That will be, if it is sp3 carbon is there, then it may be automatically it is having, according to the earlier condition, which is having non-aromatic compound because it is non-planar. But due to the homoaromaticity that it is also having planar, it is an aromatic some of the compound depending upon the 4n plus 2 pi electron rule. 4n plus 2 pi electron rule. This sp3 carbon, whatever that sp3 carbon which is interrupted by the conjugation, that sp3 carbon will be placed, will be arranged or placed top or bottom of the plane, top or bottom of the 7 sp2 carbons. Top or bottom of the 7 sp2 carbons vertically. If it is 7 sp2 carbons are like that, this sp3 carbon arranged top or either bottom of the arranged either top or bottom of the 7 sp2 carbons. 7 or whatever that, if it is depending upon this molecule, remaining sp2 carbons, arranged top or bottom, right? Then delocalization will take place, the remaining sp2 carbons only. Delocalization takes place with respect to the sp2 carbons only. Whatever the sp3 carbon is there, that it will be placed in the top of the ring. Top or bottom of the ring, it may be arranged, right? Then continuous delocalization takes place, hence that if it is follows the 4n plus 2 pi electron rule, 4n plus 2 pi electron rule, if it is follows, that it is having aromatic. It is having aromatic. Other than if it is there, that it is having non-aromatic. You may consider aromatic or non-aromatic only due to the homoaromaticity. Suppose the example, some of the examples which is mentioned, cyclooctatrinyl cation. Cyclooctatrinyl cation. Cyclooctatrinyl cation. This cyclooctatrinyl cation. So here sp3 carbon which is there, one sp3 carbon which is present. Due to the sp3 carbon, what will be happening? This is non-aromatic, but experimentally this compound is aromatic. Experimentally this is aromatic. Generally this is non-aromatic. Why? Because sp3 carbon is there non-planar. There is no planarity in the ring system. But experimentally it is aromatic. That will be explained by the homoaromaticity. The homoaromaticity that it may be happened due to the this sp3 carbon, whatever that sp3 carbon will be placed. This sp3 carbon will be placed top or bottom of the ring, right? This position. So here, this continuous delocalization takes place due to the 7 sp3 carbons only, 7 sp2 carbons only, this position. This sp3 carbon will be placed in the top or bottom of the ring, 7 sp2 carbon. So continuous delocalization takes place, only 7 sp2 carbons only. The delocalization takes place, continuous delocalization, only this 7 sp2 carbons only. 1, 2, 3, 4, 5, 6, 7. 7 sp2 carbons only. Hence, this 7 sp2 carbons, here it is follow 3 pi electrons, 3 pi bonds will be there. So what will happen? 4n plus 2 pi electron, if it is follows or not, you can check them. 4n plus 2 pi electron rule is follows. N value if it is 1, then it is having 6 pi electrons will be there. 6 pi electrons, 3 pi bonds will be there, and hence 4n plus 2 pi electron rule followed. Haeckel rule is followed, then it is having aromatic. Then it is having aromatic due to the homoaromaticity. Due to the homoaromaticity, aromatic, or it is a homoaromatic compound. Homoaromatic compound. Right. Next, some other one example. If you can take another one more example. This compound, right? So here sp3 carbon which is there, that it may be arranged in the top of the ring, top or bottom of the ring as remaining sp2 carbon positions. So though it is sp3 carbon, but it is having arranged at top of the ring position. So that is having top of the plane or top of the ring position, that it is having not involved in the continuous delocalization, only these 3 and 2, 5 bonds only which is involved in the continuous delocalization. So here it is 5 pi bonds means here it is 10 pi electrons will be there. So this 10 pi electrons which is going to 4 into 2 is 8, 8 plus 2, that means 4n plus 2 pi electron rule is followed. This is having aromatic compound. This is having aromatic compound. So in this position, suppose nitrogen atom will be there. Actually this molecule is like this. This molecule is like this. This sp3 carbon will be placed like this, out of the plane, arranged at top, out of the plane, top or bottom, out of the plane, right? Next, suppose another one more nitrogen atom. NH or NH. So if it is arranged NH, though it is a lone pair of electrons which are there, but that lone pair of electrons which are not part of the delocalization, because this is having out of plane. Nitrogen will be having out of plane, arranged in the out of plane, top or bottom. So that's remaining carbons. So delocalization takes place with respect, continuous delocalization will be there. So these sp2 carbons positions only. So hence 5 bonds will be there. Then it follows 4n plus 2 pi electron rule, 10 pi electrons will be there. It is having aromatic, homoaromatic compound. Homoaromaticity is follows. Right? If it is oxygen. Next, suppose another one more example, another one compound. Oxygen, if it is there. Oxygen atoms are there. When it is oxygen atoms are there, this is also having a arranged in the out of the plane. So what will happen? Here it is 4 and 3, 7, 14 pi electron system. Then 14 pi electron system is also n value if it is 3, 4n plus 2 pi Haeckel electron rule is follows. So it is 4n plus 2 pi electron rule is follows. Then it is having aromatic. If it is more than one sp2 carbon, sp3 carbons also there. Similar like this earlier example. So here it is sp3 carbons if it is there like this. sp3 carbon will be there. So these two sp2 carbons will be arranged in the out of the plane. So continuous delocalization takes place like this remaining rings. This is aromatic due to the homoaromaticity. homoaromaticity. Due to homoaromaticity, all these are aromatic compounds. And another one more aromatic, another one or two examples. The condition is if it is follows 4n plus 2 pi electron rule, otherwise it is not happening, right? Otherwise it is non-aromatic compound. Right, another one more compound, it is aromatic due to the homoaromaticity, this compound will be aromatic compound. So here it is. I can mention here this compound is aromatic or not. Here it is. Due to the homoaromaticity with respect to this one, another one sp3, another one position with respect to this, another one sp3, another one sp3. All it may be having arranged at the out of the planes. There are 6 sp3 carbons will be arranged on the out of the plane with respect to the 6 rings, and continuous delocalization will be there, and the number of pi bonds 1, 2, 3, 4, 5, 6, 7, 8, 9 pi bonds will be there. 9 pi bonds. These 9 pi bonds which is having 18 pi electrons. When it is 18 pi electrons are there, which is having 4n plus 2 pi electron rule is not follows or not. N value if it is 4, 18 pi electrons will be there. If n value is 4, then what will be happen? 18 pi electrons will be there. So then 4n plus 2 pi electron rule is there. According to the homoaromaticity, though is sp3 carbon positions, according to the homoaromaticity, this is this compound which is having aromatic. This compound which is having aromatic. This is homoaromaticity, some of the examples of the homoaromaticity. If a molecule getting the aromatic, anti-aromatic in a aromatic and anti-aromatic type of arrangement, preferentially takes aromatic character, anti-aromatic and opposes the anti-aromatic, character. For a molecule, due to the arrangement of the pi electrons, pi bonds, if aromatic and anti-aromatic is both are possible, preferentially takes aromatic and opposes the anti-aromatic compound character. So, for example, in the biphenyline, in the dimerization of biphenyline, the dimerization of benzene. So here in this case, this dimerization of benzene, so what will happen in the biphenyline? Like this will be happen. Biphenyline. In this biphenyline, this arrangement, which is highly unstable arrangement, unstable arrangement. Why? Because though it is, we feel that both rings will be an aromatic. Here it is. These double bond will be shared between the benzene ring and the cyclobutadiene ring. This is also between this butadiene ring and another one ring. So that means due to that, this you can take, suppose this ring independently sharing this is having anti-aromatic character. Anti-aromatic cyclobutadiene, anti-aromatic character. 4 pi electrons will be there. 4 and pi rule it may be followed. We may feel this is an aromatic, but this combination which is having anti-aromatic. If it is there, this compound will be arranged. If it is suppose like this, so this pi bond suppose here in these positions, and another one suppose here in these positions. This is completely aromatic, but this is shared between these two. So this is also somewhat unstable. Then another possibility is like this. This is going to be here in this position. This one is not fully aromatic. This is aromatic, right? So another possibility is by changing the pi bonds only. Another possibility is these two rings completely independently. This is an aromatic, and this is also having aromatic. Here there is no anti-aromatic character of this beta cyclobutane case. This case there is no anti-aromatic. This is aromatic and this is also aromatic. This is stable, right? So there is for a molecule to getting the aromatic and anti-aromatic character, probably or preferentially takes aromatic character and opposes the anti-aromatic, whatever that anti-aromatic if it is there, that it will be having opposes that anti-aromatic, even though non-aromatic also it is opposes, only having takes aromatic character. The arrangement of these pi bonds. Suppose in another one more, for this molecule, if it is fully aromatic, the arrangement of the pi bonds like this. Like this. So there is no pi bond sharing this this position and this position. Like this, it is not there. So this is fully aromatic, this is fully aromatic, this is fully aromatic, this is most stable compound. If suppose you can draw another one more like this. This is also fully aromatic. If a molecule, whatever the molecule, further also so many of the examples I can take. If a molecule to getting aromatic and anti-aromatic, preferentially takes aromatic character and opposes the anti-aromatic. This is highly stable compounds will be formation takes place if it is completely aromatic, both rings. Next another molecule is fulvene molecule. The aromaticity of fulvene, right? In this molecule, like this, there is an exo double bond or exocyclic double bond, exo double bond which is there. This is there. This is exo double bond. With respect to this exo double bond and with respect to this exo double bond, substitutions also there in place of hydrogen atoms also, that will be decided by the aromaticity in the fulvene molecule. If it takes fulvene molecule in the exo double bond, with respect to this, always the negative charge in this molecule, fulvene molecule, the double bond, the polarization takes place when it is always shifted towards the negative charge always shifted towards the or polarizing towards the ring side. ring side. Why? Because ring side for getting aromaticity. So if it is negative charge going to be like this, that means what will happen here in this case? The most stable structure and plus it may be there. If you can take this 4n plus 2 pi electron rule is follows, 6 pi electrons will be there. 6 pi electrons means 4n plus 2 pi electron rule is follows, and value if it is 1. These 2 pi electrons and negative charge is also 2 pi electrons, 6 pi electrons. When it is 6 pi electrons which are there, that is having 4n plus 2 pi electron system which is there, continuous conjugation which is there, and which is having aromatic. So that's why in the stability point of view, getting aromaticity, while negative charge polarized towards the rings side, 5-membered ring side. This 5-membered ring and getting aromaticity, right? If it is, with respect to this aromaticity, if it is otherwise, suppose if it is polarization towards this side, what will happen? In another direction, not ring side, what will happen? Like this type of structure will be there. So that means when it is positive, negative charge is like this and positive charge is like this. If otherwise not this is happened, suppose towards other side, out of the opposite to the ring side. So what will happen? This is also sp2 carbon which is there, planar it may be there, but here it is compared to this ring, this is anti-aromatic character which is there. Anti-aromatic because 4n pi electrons will be there. 4 pi electrons will be there. N value if it is 1, 4 pi electrons will be there. This is double 1, this is double 1. Double 1 indicates 2 pi electron. Here it is 4 pi electrons will be there. It is follows 4n pi electron rule. Anti-aromatic. Anti-aromatic if it is there, that it may be having unstable compared to the aromaticity. So that's why this one is not preferred. This is preferred structure is like this, right? So existing the dipolars, positive charge and negative charge both are existing. It is a dipolar structure. Dipole moment is also it may be shown. With respect to this exo double bond, substitutions if it is there in the following molecule. Suppose the substitutions which are there in the following molecule, that substitutions are electron withdrawing group it may be there, and electron donating groups will be there. Electron donating groups will be there and withdrawing groups will be there. Suppose electron withdrawing group which is there and electron donating group which is there. What will be happen? And which one is having more aromaticity? Electron withdrawing group and electron donating group. If it is withdrawing group is there, donating group if it is there. So donating group which is present here in this position, like this, right? So donating groups plus charge and minus charge for this, right? And donating groups which is there, when it is donating groups which are increases the, because already positive charge will be there, right? When it is donating groups are there, in presence of the donating groups, increases the stability of the carbocation, So that's why increases the stability of the carbocation. Stability of carbocation is increases due to the which one? Donating groups. Due to the donating groups, electron donating groups. So that's why this is when the donating groups which are there, electron donating groups, the stability is increases, it is getting more dipole moment is also, more dipole moment, more aromaticity is also. And with respect to this, withdrawing groups which is there, if it is withdrawing groups are there, in presence of the withdrawing groups, what will happen? Carbocation, already here it is electron deficient, positive charge will be there. So electron deficient, again withdrawing groups will be there. That's why it may be the withdrawing groups are decreases the stability of the carbocation. So that's why this is compared to this donating groups, this is having less stable because withdrawing groups are decreases the stability of the carbocation, right? So that's why when it is dipole moment is also, if it is once the donating groups will be there, that stability of the following molecule increases compared to the withdrawing groups. Compared to the, there is no groups, here it is simple molecule, right? This is the order, stability order, and aromaticity order is also in the following molecule with respect to the substrate. With respect to the substrate. And dipole moment is also increases. While dipoles are existing, when dipole moment is increasing, once the donating group capacity is also increasing, once the donating group capacity is increasing, dipole moment is also increasing. Dipole moment is also increasing. So here in this case, suppose the molecule hydrogen, this is dipole moment is suppose 1 mu d, methyl 1.48 d by units will be there, phenyl is more compared to the methyl, so this is 1.9 d, and another one which is having NEME2 dimethylamine. So here it is more donating capacity will be there. So here it is nearly 4 d by will be there, and this is 1 d by. So that means strength of donating group donating capacity is increases when stability of the carbocation increases, and as well as the dipole moment is also increases in the following molecule. When it is the negative charge is polarized towards the ring side, then it is getting aromatic character, stable point of view. All right, following molecule. If you can take the calcine, similar like that, calcine system. The calcine molecule. What will be happen? We can see 1 or 2 examples or generalized case. Which one is aromatic, which one is anti-aromatic? In the examination's point of view, questions are there, right? The calcine system. Suppose if it is given a 5-member ring, and with respect to that it takes a double bond, 3-member ring which is there, right? This is getting stability. How it is getting stability? That means the negative charge polarized towards which side, positive charge polarized towards which side, right? Existing the dipoles also it may takes place, right? If it is negative charge is polarized towards this, what will happen here? It is 5-member ring side, then it is getting aromatic, and here it is positive charge will be there, negative charge and positive charge. This ring independently, this ring is which one? 6 pi electrons will be there, and 4n plus 2 pi electron system is follows, and which one? This is aromatic. If you can take this, here it is 2 pi electrons will be there, sp2 carbon here it is there, sp2 which will be there. So 2 pi electrons will be there. When it is 4, n plus 2 pi rule is follows, n value is 0, what will be happen? 2 pi electrons will be there. Hakel 4n plus 2 pi electron rule is follows. This is also aromatic. This ring is independently aromatic. This is aromatic. Whole molecule is also getting aromatic character. So that's why here it is negative and positive charge. If it is suppose positive and negative will be there, both are having anti-aromatic, right? Suppose 7-member ring which is there. Seven-membered and 5-membered ring which is there, right? The most stable dipolar structure which is which one? It may be there to getting the ring is aromatic. Here already 6 pi electrons will be there, right? If it is towards 5-member ring side, then it is having positive charge. So then what will be happen? Tropylium cation. This is which one? Tropylium type cation. Tropylium cation, it may be there independently this ring. So 6 pi electrons will be there, and which is having aromatic. 4 and plus 2 pi electron rule is follows. And here it is negative charge, right? Here it is also 2 pi, 2 pi, 4 pi electrons, and negative charge indicates 2 pi electrons. So here it is also 6 pi electrons. This is also aromatic character, can be shown independently. This is also aromatic character. And already we have seen the cycloocta tetraene, which is having cycloocta tetraene, if it is non-planar due to the tube shape existing in the tube shape form, non-planar. So that's why it is non-aromatic instead of anti-aromatic, non-aromatic. Right? Cycloocta tetraene we have seen already in the, I explained that in the earlier one. Cycloocta tetraene, which is having non-aromatic, not anti-aromatic, non-aromatic. Why? Because non-planar. If it is reacting with 2K, 2 metal, when it is addition to the 2 electrons, what will happen? This molecule is getting like this, minus 2. When it is like this, delocalization takes place and minus 2. Another one more example. Questions like this, another one of the exam point of view. Here this molecule in presence of base, which another one molecule is given. In presence of base, which one is more acidic? Which one is more acidic? And mention this: less pKa value and pKa value is more. pKa value is more, or larger pKa value. Larger pKa. Which one is more acidic? Which one is more acidic in presence of base? So, which one is more acidic in presence of base? If it is losing H plus ion, so what will happen? Losing H plus ion. So here it is negative charge will be there. When it is negative charge will be there, what will happen? This ring is getting aromatic. This ring is getting aromatic. More stable will be there. And if it is by in presence of base, H plus is losing. So what will happen? Here it is negative charge will be there. So here it is 2 pi, 2 pi, it is going to be anti-aromatic. Anti-aromatic. This is aromatic and this is anti-aromatic. So, and aromatic it may be there stable. So while in presence of base, a more stable compound will be takes place. So this is going to be more acidic in nature. More acidic in nature, and this is least acidic or less acidic in nature compared to this. Acidity is more acidic and least acidic, right? So if it is less pKa is there, that is having more acidic, and more pKa is there, that is having least acidic in nature. Least acidic in nature. And another one more example. Which one dipole is which of the molecule is having more dipole moment with respect to the carbonyl? Larger dipole moment is existing in which molecule? Suppose with respect to this carbonyl, if it is with respect to this carbonyl, if it is existing the dipole towards oxygen atom side, what will happen? If it is existing the dipole, so in the first molecule, with respect to this carbonyl, if it is O minus and positive charge will be there, and pH O minus and positive charge and phenyl. Here, this molecule, to exist the dipoles at the carbonyl, so then dipole moment is existing with respect to this, here it is dipole moment, but with respect to this dipole moment, carbonyl, this molecule, double bond and positive charge is there. This ring is getting aromatic. But here it is, there is no additional advantage due to the establishment of the dipole. This molecule is, there is no additional advantage, but here it is getting more, here it is aromatic character, it may be shown. So that's why here it is, larger dipole moment is there, more dipole moment is present, this molecule. Right? First one molecule is more dipole moment than the second one molecule. And in another one more examination point of another one question. Which oxygen is faster taking H plus ion? Which oxygen is taking faster H plus ion? Which one is taking faster H plus ion? Which oxygen? Which one is taking H plus ion is faster? Which one is taking H plus ion is faster? Here it is lone pair of electrons will be there. Here it is also lone pair of electrons will be there. Unpaired electrons will be there. Which one is taking faster? Which one is taking faster? If it is taking this faster, right? So suppose if it is carbonyl is taking, what will be happen? Carbonyl is taking, what will be happen? Here it is, positive charge will be there, and suppose OH, positive charge will be there. So here it is, what will be happen further? OH, positive charge, like this. If it is taking this one, OH positive charge like this. If it is second one oxygen is taking. If it is first one oxygen is taking, if the carbonyl oxygen is taking H plus ion, suppose what will happen, this ring is going to be double bond, 2 pi electrons, and here it is lone pair electron. This ring is getting aromatic. This 2 pi electrons and here is 2 double bonds, 2 by 2 pi electrons. Totally 6 pi electrons will be there. Aromatic 4n plus 2 pi electron rule is follows. Here it is not there like this. Within the ring it is not there. So that's why the first one, the carbonyl oxygen is faster taking H plus ion rather than the another one ion. This is faster taking H plus ion will be the carbonyl molecule. And suppose another one more example. Which one is having aromatic? Which one is having non-aromatic? Or anti-aromatic? Which one is aromatic? Which one is anti-aromatic? Anti-aromatic is which one? Aromatic is which one? See here it is sp3 carbon which is there. So it is definitely non-aromatic, non-planar, and charged species are always existing as the planar. That is planar, which one it is anti-aromatic or aromatic which will be there. So here it is positive charge will be there. Here it is 2 pi electrons will be there, lone pair of electrons. And total how many electrons? 6 pi electrons will be there. So it is getting aromatic And here it is oxygen, 2 pi electrons will be there, that lone pair electrons which are involved in the conjugation, that it is having which one? That it is considered as the Hakel lone pair, a double one which is involved in the conjugation, and 4n plus 2 pi electron rule, that is having Hakel double bond also. So here it is 2 pi, 2 pi, 2 pi. And here it is again 2 pi electrons will be there. Total 8 pi electrons. 8 pi electrons means 4n plus 2 pi, 4n pi electron rule is follows. So that is getting anti-aromatic character. It is anti-aromatic. Anti-aromatic. In the examination point of view, so there sometimes directly questions are not there, which this aromaticity related type questions will be there. After reacting with so and so compound, formation takes place. If it is getting aromatic, it is fully aromatic. It is more stable, more aromatic. Right? Sometimes if it is base is given, which one is least acidic, more acidic, it is related to the aromaticity also. You can explain that. Right? Next, another one. Suppose which one is more acidic in the following examples? Which of the following hydrocarbon is more acidic in nature? Which of the following hydrocarbon is more acidic in nature? Which of the following hydrocarbon is more acidic in nature? Another one more example is which of the following one is more acidic in nature? Which of the following hydrocarbon is more acidic in nature? See, listen. If it is more acidic in nature, is which one it may be there? Right, here this example is given like this. Right, in these 4 examples, which of the following hydrocarbon is more acidic in nature? Suppose if it is, here it is hydrogen, it may be there, suppose with respect to double bond. If it is H minus hydrogen, if it is losing takes place, what will be happen here? It is negative charge. With respect to this negative charge, suppose if it is polarization towards this negative charge, and this is going to be negative here in this position negative. But there is no additional advantage to this ring. There is no additional advantage to this ring. If it is this position, if it is hydrogen atom, if it is losing takes place, which one is more acidic? So that's why if it is H plus is losing takes place, negative charge will be there. This is shifted towards this ring, suppose, and this shifted towards this ring in this position. But there is no additional advantage if it is takes place here in this position. There is not getting an aromatic character, or not enhances this stability due to that conjugation, it is not increasing. Suppose here in this position, if it is hydrogen is losing takes place, hydrogen atom, suppose if it is position hydrogen atom is losing takes place, what will be happen here? It is negative charge will be there. If it is negative charge, suppose polarized towards this, suppose this, what will be happen here? It is negative charge will be there, right? A double bond, and here it is negative charge. Due to this negative charge, there is no extra stability of this ring, because here it is already sp3 carbon will be there, so there is no aromaticity. So if it is here in this position, suppose hydrogen atom is there, if it is losing takes place, what will be happen? The 4th one example case, suppose you can take this one, here it is negative charge will be there, suppose this negative charge polarization towards this, suppose what will be happen in this ring? Here it is negative charge, and like this will be there. This ring is getting aromatic character. This ring is getting aromatic. Here 2 pi electrons, and negative charge is also it's in 2 pi electrons. So it is having aromatic. So that's why if it is this hydrocarbon, if it is this hydrogen, if it is losing, getting aromatic character, more stable. So that's why which one is more acidic? This one is more acidic. Out of these 4 examples, this is this hydrocarbon which is having more acidic. Right? This is one examination point of view question will be there. Suppose another one more example. Which one is more acidic in the methyl? Which one is more acidic in the molecule? Which one? Sorry, here it is already double bond is there. Why it is double bond? There is not requirement of the double bond. Methyl. Here this methyl and here it is methyl. If it is there, suppose this is A, this is B. Which one it is more acidic? Which one is more acidic? Either A or B is more acidic. If it is B, suppose proton, if it is losing takes place, what will happen from the B? CH2, CH, in this case, minus will be there, CH2 minus. For getting, here it is, methyl will be there. If it is B proton, if it is B is losing, what will be happen? Methyl, if it is there, negative charge will be there, here in this position, CH2 minus. So due to this negative charge, if it is, there is no conjugation from this, here it is double bond is there and here it is there. Additional conjugation is not happened, right? If it is takes place here, this double bond is in conjugation with this negative charge is conjugation with this double bond. But here it is with respect to this is conjugation is possible, with respect to this is conjugation possible. But here it is those two are not in conjugation. But here it is possible. Right? Here it is possible with respect to this ring. So that's why if it is proton is losing from A, it is more acidic. This is B, this is A. B proton is losing, it is A proton is losing. So A is more acidic than B. A is more acidic than B. Sometimes questions are there, which one is more acidic in nature, which one is least acidic in nature. Or sometimes question will be there, double bond O, phenyl, in presence of HBr, reaction is fast, why? In presence of HBr, reaction is fast. Why means here it is phenyl, OH plus Br will be there, Br minus, H plus Br minus. Here with respect to when it is HBr reacting with HBr, this ring is getting aromatic character, 4n plus 2 pi electron rule is follows. This is getting aromatic, so that's why this reaction will be takes place fast. Suppose in presence of water, when it is Br is there, in presence of water this reaction is fast. Why? Because cycloheptatrinyl or tropylium cation formation takes place. Br minus. Tropylium cation formation takes place. It is getting aromatic. To getting aromatic, the reactions maybe also takes place fast. More stable formation takes place. If it is another one more example, Cl will be there. The loss of Cl minus which is takes place fast. Why? Because by losing Cl minus, what will be happen here? It is positive charge will be there. Positive charge. Positive charge. The loss of Cl minus, positive charge will be there. This ring is getting, remember, ring is getting aromatic. Right, 4n plus 2 pi electron rule is follows, so that's why it may be losing Cl, loss of Cl minus, which is loss of Cl, which is reaction is fast. Whatever that you can use, fast that it may be happening. Why? Because aromatic character stabilize, stable compound formation takes place. Right. Next, suppose another one more. If it is in projects of if it is two equivalents of n-butyl lithium, what will be happen? It is two equivalents of n-butyl lithium with will be added in the reaction. So here it is loss of hydrogen ion. So loss of hydrogen, H plus ion, proton. Here it is negative charge is generated. Here it is negative charge is generated. What will be happen? Negative charge is generated. Here it is negative charge is generated. Here it is. Sorry, here it is. That is not correct. So it's happening. Okay. So total is how many electrons? 6 pi and 4 pi. 6 and 4, 10. 10 pi electrons. It is getting aromatic. Right? Somewhat. And another one more example. So the stable structure of stable resonance structure of this molecule. Stable resonance structure, it may be shows which one, how to show that. The examination point of view given, so many options will be there. I can write correct one here. It is show stable resonance structure. It is the double bond indicates positive charge and negative charge. Here it is negative charge and positive charge. I mentioned that. Nitrogen I cannot disturb. So with respect to this, what will be happen? Ring is getting aromatic. Ring is getting aromatic. Right? And another one more. Which one is? Which of the following molecule? Which of the following molecule is the hydrocarbon which is having more acidic in nature? Which of the following hydrocarbon is more acidic in nature? Which one is more acidic in nature? Right. For this, suppose proton is losing. Right? Proton is losing, minus charge is there. But here it is sp3 carbon is there. So there is no getting extra stability. If it is this position, if it is by the loss of H plus ion. So what will be happen by the loss of H plus ion? Here it is minus charge will be there. So total is 10 pi electrons. This ring is getting aromatic, or with respect to this ring is aromatic and this one ring is independently aromatic. What if it is this position, if it is proton is losing takes place? So what will be happen? Total is having how many pi electrons? How many is there? 12 pi electrons. It is anti-aromatic. It is anti-aromatic. It may be there. But here it is. Which one it may be there? This is aromatic. This is aromatic. So that's why which one is most acidic? This is more acidic in nature. More acidic. Right. Next, in the case of the annulenes, what will be happening in the annulenes? Next one is in the annulenes. Which annulenes are aromatic? Which one is non-aromatic or anti-aromatic? 10 annuline. 10 annuline. So 10 annuline it may be existing in the 3 isomeric forms. Whatever the isomeric form you can select, that it may be having non-aromatic. Non-aromatic. 10 annuline is having non-aromatic. 10 annuline is having non-aromatic. So due to the transangular interactions between the hydrogens, these two hydrogens, due to the transangular interactions between the hydrogens, if it is, you can select it as another one form like this, all it may be eclipsed form, 10 like it may be a round shaped manner, you can write. So due to the eclipsed interaction, it may be deviating from the 120 degree of the bond angle, naturally which is existing in the 10 annuline case, 144 degrees of bond angle it may be there, that it may be deviation, it may be there from the eclipsed bond angle also. So here in this case, transangular, due to the transangular interactions between the two hydrogens, existing somewhat steric crowding it may be there. Due to that, loss of planarity is existing. Loss of planarity. That means in the existing 3 isomeric forms, that all these 3 isomeric forms will be in loss of planarity, that it may be having non-planar. Non-planar. If it is non-planar, then that it may be having immediately, which is considered as the non-aromatic. Non-aromatic. Though it is having 5 pi bond, 5 double bonds are there, 10 pi electrons are there, 4n plus 2 rule if it is follows. But here it is, due to the non-planar structure, this 10 annuline which is having non-aromatic. Non-aromatic. In this case, transangular interactions between the hydrogens, steric crowding it may be existing. In another one form, eclipse deviation also takes place. Due to the bond angle deviation it may takes place. If it is 12 annuline, and this 12 annuline is aromatic or non-aromatic or anti-aromatic. 12 annuline. Like annuline is like this. 12 annuline. So 12 carbon atoms will be there. 12 annuline it is. This 12 annuline is follows 4n pi electron rule. 4n pi electron rule. 4n pi electron rule. If it is 4n pi electron rule is follows, n value if it is 3, 12 pi electrons will be there. N value is 3, 12 pi electrons. So 4n pi electron rule is follows. Based on that 4n pi electron rule, if it is generally anti-aromatic, but if it is, that it may be happened in the planarity of the ring system if it is existing. This depends upon two conditions. If it is planar, that it is having anti-aromatic. Due to the existing the structures also it may be somewhat difficulties it may be there. I'm not going to detail the discussions. Suppose if it is planar, anti-aromatic. If it is non-planar arrangement it may be there, that it is having non-aromatic. Non-planar, non-aromatic. Non-aromatic or not aromatic. And 14 annuline. Another one case it may be having 14 annuline. In case of the 14 annuline, what will happen? Like this similar structure. So, but here it is one carbon is extra in this case, and here it is also one carbon is extra. So total it may be 14 carbons will be there. Compared to this, 2 carbons are extra like this. 14 aniline, 14 aniline. This 14 aniline, 14 aniline, it may be having 4n plus 2 pi electron rule is follows. If n value is 3, so 14 pi electrons will be there. 14 pi electrons will be there in the 14 aniline. So each carbon sharing on 1 electron, 14 pi electron which is there, 1 pi electron. So 4n plus 2 rule is follows. 14 pi electrons it may be there. Total 7 double bonds are there. So due to the 4n plus 2 pi electron rule is follows, Haeckel rule is follows. If it is this one is planar, so then it is having almost it is maintained the planarity. So it is having aromatic. Aromatic. Next 16 aniline. What is 16 aniline? 16 aniline. Aniline. In the 16 aniline, so here it is 4n pi if electron rule is follows, because n value is 4, directly 16 pi electrons will be there, 8 double bonds will be there, 16 pi electrons will be there, 16 pi electrons, then which one it may be there, 4n pi electron rule is follows, n value is 4, 16 pi electron rules. Then it may be, which one it may be happening, this is anti-aromatic. 16 aniline is anti-aromatic. It is not aromatic. Either it is anti-aromatic or non-aromatic. So it is not aromatic, then immediately we can say it is anti-aromatic or aromatic. Definitely it is planar repeat system is there. It is a anti-aromatic. So in this case, the inner protons and outer protons will be there. Inner protons and outer protons. Here it is inner proton, here inner proton, inner proton. This chemical name is also another one, it may be there. Different names also it may be there. There are 12 outer protons will be there and 4 inner protons will be there. 4 inner protons. These inner protons, chemical shift values are more. Inner protons chemical shift values are more. Delta chemical shift values are more. And outer protons chemical shift values are more, less. Outer protons delta chemical shift values are in ppm, chemical shift values are less. When inner protons chemical shift values are more, that may be having considered as paratropy. That it may be having paratropy in nature. Paratropy in nature. In NMR studies case, proton NMR studies case. Right? In case of the anilines. 16 aniline, how can you differentiate? By using the proton NMR like this. 18 aniline. Whether it is aromatic or not. Aromatic or not. 18 aniline. In 18 aniline, like this. 18 aniline. This 18 aniline is also inner proton, 6 inner protons are there, 12 outer protons are there. This 6 inner protons and outer protons is there. This opposite come quite opposite to the. Here in this case, inner protons chemical shift values are more, but here it is inner protons chemical shift values are less. Inner protons delta chemical shift values are less. That means outer protons delta chemical shift values are more. Outer protons delta chemical shift values are more. When it is inner protons delta chemical shift values are less, that it may be having diatropy in nature according to the proton NMR point of view. So when it is inner protons delta chemical shift values are less and diatropy, that it is having aromatic in nature. 18 aniline. 18 aniline it is follows. How many pi bonds are there? 9 pi bonds are there. 18 pi electrons will be there. which is follows 4n plus 2 pi electron rule. When n value is 4, suppose 16 plus 2, 18. 18 electron rule is follows. When it is, that's why it is, 4n plus 2 rule is follows. Then it is 18 aniline, which is considered as aromatic in nature. 10, 12, 14, 16 and 18. Like the 22, if it is there, whatever it may be, 20 aniline, 22 aniline, depending upon that number of pi electrons in the system. Whether it is 4n plus 2 pi electron rule is follows or 4n pi electron rule is follows. So depending upon that, anti-aromatic or aromatic in nature. Anti-aromatic or aromatic in nature. Next, another one is the Craig's rule. Craig's rule. So Craig's rule is applicable for polycyclic. This is also to define that means to explain the aromaticity, and that means aromatic compound, whether it is aromatic compound or non-aromatic compound, by using the Craig's rule. So this is applicable for polycyclic non-benzenoid compounds. Polycyclic non-benzenoid compounds. Polycyclic non-benzenoid compounds, which this rule is applicable. And in this rule, the molecule, we can select the molecule which can pass through the C2 axis or contain the C2 axis. The molecule, select the C2 axis. That means the molecule contains C2 axis. With respect to C2 axis, the rotation will takes place. During that rotation, it produces new Kekulé structure. That it may be necessary. The arrangement of the pi bonds also it may be necessary to produce new Kekulé structure. We can select the C2 axis, which during the rotation it produces new Kekulé structure. New Kekulé structure will be produced. The double bonds will be exchanging takes place. That selected C2 axis must. After the selection of the C2 bonds, C2 axis, spin labelings will takes place. Further, it may be number of spin pairing positions which are exchanging takes place. Number of spin positions will be opposing takes place. Number of spin positions are exchanging, that it may be F. Suppose small f, number of spin pairing positions, if it is opposites, that it may be having beta, G. F plus G is equal to odd number, that it may be having anti-aromatic. F plus G is non-aromatic. F plus G is even aromatic, that it may be one kind, it may be there due to this spin labeling point of view. But in another way, it is also there, that may be very easy to calculate the total number of double bonds. After that, calculate the total number of double bonds. After calculation of the total number of double bonds, that it may be having capital N. These double bonds also particularly exchanging the positions. If n minus 1, n is the total number of double bonds. If n minus 1 is equal to odd number, that it is having non-aromatic. It is not aromatic. This rule can explain only aromatic or not. That's only. It is anti-aromatic particular, that it may be not explained. If n minus 1 is equal to even number, that compound which is having aromatic based on even number and odd number. Suppose we can take that it may be have this it may be takes the double bonds like this. Suppose I mentioned that if it is benzene, suppose you can select, this is benzene, suppose you can select the C2 axis which is passing through the C2 axis. Suppose what will happen, if it is rotation takes place, same structure is producing this double bond, this position, this ring is here in this position, So same structure is produces, same structure. These two are same structures. So that's why we cannot select this type of C2 rotation. That means not this one. If it is going to be this one also, same structure it may be there. So then you can select, even though it is, so this was not explained by this naphthalene is not explained by the Craig's rule, but I can explain. The selection of the C2 axis during the rotation, it produces new cakeless structure. It produces new cakeless structure. So like this, you have to select. This ring is, I mentioned that in the earlier one, to getting the aromatic character and aromatic character, it always takes the ring takes the aromatic, fully aromatic. At double bonds are in conjugation. If it is during the C2 rotation takes place, what will happen? It produces new cakeless structure. That means this position is going to be here in this position. This one is going to be here in this during the rotation. This one position is here, and this one position here in this position, here in this position. You take this ring, the double bonds are exchanging takes place. While you can consider these two, this is new cakeless structure. New cakeless structure. Number of double bond positions are exchanging takes place. Number of double bond positions are 5 bonds are exchanging takes place. All 5 double bonds are exchanging takes place. 5 double bonds are exchanging takes place. N value is 5, 5 minus 1, that is equal to even. That is having aromatic. Right? According to the Craig's rule. Right? According to the Craig's rule. Azulene, you can take the compound. Azulene. Azulene is what will happen? One 5-membered ring and one 7-membered ring. One 5-membered ring and another one it may be having 7-membered ring. One 5-membered ring and 7-membered ring which is there. Azulene is the compound, one 5-member ring and as well as 7-member ring which is there. Azulene is the compound, like this. If it is, you select it. Here conjugation if it is there. Conjugation is not interrupted, conjugation is there. There is a 5-member ring and 7-member ring which is there. 5-member as well as 7-member ring is which is there. In this azulene, select C2 axis. Select C2 axis. If it is rotation takes place, this is going to be upper and this is going to be down. Rotation takes place with respect to C2 axis. Rotation takes place. If it is rotation takes place, what will happen? This double bond, this position, this double bond, this position, this is going to be here in this position, this is here in this position, this is here in this position. Total number of double bonds are exchanging that, total 5 double bonds are exchanging that positions. So that means n minus 1, if it is takes place, that means 5 minus 1, that is called 4. 4 is which number? Even number. When n minus 1 takes place, even number, that it is having aromatic. That it is having aromatic. That is having aromatic. Azulene is aromatic. It is a deep blue colored compound. The resonance energy which is having 49 kilocalorie per mole. 49 kilocalorie per mole for resonance energy which is there. And which is also existing its dipolar structure, dipole moment is which is there, 1d by dipole moment which is there, due to the higher dipole moment which is existing, due to the charged species which is existing, dipole structure will be existing. In this dipole structure of this azulene, dipolar structure of the azulene, the 7-member ring which is having the positive charge and 5-member ring which is having the negative charge will be there. 5-member ring which is having the negative charge. Suppose like this, the azulene of the 7-member ring which is having positive and, sorry, 7-member ring positive. Positive charge will be there in the 7-member ring. Due to that positive charge will be existing in the 7-member ring, here it is nucleophilic substitution reactions takes place. Nucleophilic substitution reactions takes place at 7-member ring. 7-member ring, nucleophilic substitution reactions takes place on azylene. In 5-member ring, negative charge will be there in the 5-member ring, negative charge and positive charge will be 7-member. 5-member ring which carries the negative charge, due to that electrophilic substitution reactions takes place. Electrophilic substitution reaction takes place on the 5-member ring, and 7-member ring, due to the positive charge, what will happen? Nucleophilic substitution reactions takes place on the 7-member ring. It is a deep blue colored compound will be there in the azylene. Azylene will be existing in the deep blue color compound. Right? If you can see the stable structure of this azylene. Here positive charge will be there. Here negative charge will be there. This one ring, if you can take this is aromatic, and this is also getting aromatic. Aromatic. So this is fully aromatic and this is also fully aromatic, right? So this is the stablest structure. This is the stable structure of this. Which one? Azylene. Azylene. Positive charge, negative charge, it may be maximum distance, it may be there. Azylene. So the 7-member ring, and this is 5-member ring. 5-member ring, which one it may be there? Negative charge. 7-member ring is positive charge. Nucleophilic substitution takes place, and here it is electrophilic substitution reactions takes place at 5-member ring. This position nucleophilic substitution reaction. This is having azylene case. Azylene, right? If it is pentylene, if you can select the pentylene, Craig's rule can be explained, the pentylene, heptylene. Some other examples, I mentioned that pentylene, pentylene, right? Pentylene. If you can select the C2 axis, if it is rotation takes place, what will happen if it is rotation takes place with respect to C2 axis? It produces new structure. It produces new structure. Right? If it is going to be rotation takes place, this position is double bond is this position. This one is going to be here in this position, and these two are also exchanging takes place. Right? Exchanging takes place to this. Right? So this is new structure. Double bond positions are exchanging takes place. Right? So then it may be having, which one it may be there, how many number of double bonds which are exchanging takes place? 4. Total number of double bonds are 4. If n minus 1 if it is, that means 4 minus 1, that value is how much? 3. 4 minus 1 is 3. 3 is which one? Odd number. When it is odd number, then it is having which one it may be there? Non-aromatic. It is not an aromatic compound. Non-aromatic is not aromatic. According to Craig's rule, it is not an aromatic compound. Not aromatic. Pentylene is not aromatic according to the Craig's rule. And another one which is having heptylene. Heptylene, you can select the heptylene. Heptylene. Here it is also exchanging takes place, C2 rotation takes place. While C2 rotation takes place, this double bond, this position, this is going to be here in this position, this is going to be here in this position. This is here and this is here. So total number of double bonds are exchanging takes place in the during the C2 rotation. 6 double bonds are exchanging takes place. Total number of double bonds are 6. If n minus 1 is equal, that means 6 minus 1 is equal 5. So then 5 is which one it may be there? Odd number. When it is odd number, and heptalene is which one? Non-aromatic. Non-aromatic. It is a not aromatic compound. Heptalene is not aromatic. N minus 1 is odd number. Another one more example, the Craig's rule. According to that, Craig's rule can explain another one more example. This one compound, this molecule, C2 rotation, if it takes place, C2 axis it maybe takes place, C2 rotation takes place, exchanging takes place. What will happen here in this exchanging takes place during this, right? So this position double bond is here, and here this one takes place like this. This ring is here, this ring is here, and this bond is same. This double bond is same, which cannot be involved in the delocalization, that it may be non-Huckel double bond. So these 5 double bonds we can take, 5 double bonds are exchanging takes place during the C2 rotation, right? So you can take n value is 5, then n minus 1. Here total is 6, but you cannot take this, don't consider this, which is a non-Huckel double bond, which cannot participate in the conjugation, delocalization. Because here it is only during the C2 rotation, with respect to that C2 rotation, nucleophile structure is producing only 5 double bonds are exchanging takes place. N minus 1 is equal 5 minus 1, that is equal 4. 4 is a even number. 4 is a even number. When it is even number, this is having which one? Aromatic. This is having aromatic. You can ignore that simply this double bond. If here in this position, if it is another one like this structure, if it is also there, so you can also ignore this double bond. That cannot be exchanging takes place. Another one more example is pyrene. Pyrene molecule. According to the Craig's rule, only this pyrene molecule can be explained. Pyrene. Here, pyrene. In pyrene, total here it is 8 double bonds will be there, 16 pi electrons will be there. 8 double bonds, 16 pi electrons. This is a 16 pi electron system. Actually, according to the Huckel's rule, Huckel's 4n pi rule, n value if it is 4, 4n pi rule is satisfied, then it may be planar, that is having anti-aromatic. But experimentally, this is having aromatic compound. But this is aromatic compound. This aromaticity is explained by the Craig's rule. Craig's rule. If it is C2 rotation takes place, C2 rotation takes place, what will be happen? This double bond here in this position, this one is here, 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 this one is here. But this double bond is not changing that position. This double bond is not changing that position. This double bond is non-Huckel double bond. Non-Huckel double bond, which is not involved in the conjugation, not involved in the delocalization, not involved in the delocalization. Delocalization takes place with respect to this carbons only, which is this double bond is not involved. These 5 electrons are not involved. So you can select the double bonds, 7 double bonds, n value if it is 7. Even though 8 double bonds will be there, you can select it as a 7 double bonds are exchanging their positions during the C2 rotation. C2 rotation takes place, only 7 double bonds are exchanging the position, this cannot be exchanging that. N value if it is 7, then n minus 1, that means 7 minus 1, that is equal to 6. 6 is which number? Even number. According to the Craig's rule, even number which is there, that it is having aromatic. Though it is 16 pi electrons, due to the non-Huckel double bonding character will be there, then pyrene which is having aromatic. Pyrene which is having aromatic. Right? So this is the Craig's rule. This is a Greg's rule. Right? Next one is the quasi-aromatic compounds. Quasi-aromatic compounds. These compounds are quasi-aromatic compounds. So these quasi-aromatic compounds are generally ionic aromatic compounds. These are generally ionic aromatic compounds. Ionic aromatic compounds. So, for example, when it is electrophile and nucleophile, which is there, nucleophile. So here it is O minus and plus will be there. Plus is going to be nucleophile and OE plus nucleophile minus. Right? This is attacking towards this, and O minus and E is there. O minus E plus is OE. Right? So this is positive charge which is there, and 2 pi electrons which is there. So this is an aromatic compound. Aromatic compound. This quasi-aromatic compound, ionic aromatic compound. Suppose another one more example. The quasi-aromatic compound plus HClO4 in the presence of HClO4 reacting with HClO4, H plus ClO4 minus like this, O minus and H. So this is this general reaction, so I am not going to be detailed manner. Right, very OH and plus ClO4 minus. ClO4 minus. So this is also tropylium type cation ring will be there. So this is having aromatic 6 pi electrons will be there, and all are sp2 carbons, planar type of ring system will be there. Right? And another one more example similar like this. F will be there, fluorine, in presence of SbF5. So it takes F, so here it is plus SbF6 minus. So this is also aromatic compound. Also aromatic compound. And another one aromatic compound which is having, suppose Cl in presence of AgNO3, so it is losing, and plus will be there, NO3 minus. When it is reactions takes place, plus NO3 minus plus AgCl. This is also quasi-aromatic. This is also aromatic, but ionic compound is quasi-aromatic compounds. These are quasi-aromatic compounds. And some of the fused ring systems will be there. Some of the fused ring systems. And some of the fused ring systems, while we have seen some of the fused ring systems, triphenolane system. In this triphenolane system, we cannot predict aromaticity or anti-aromaticity. So if it is, you can see that suppose if we are going to be transfer of this electron towards this side, so what will be happen? This is going to be here plus minus like this. If you can take this system is aromatic. If this one you can take 4 pi electrons, right? 4 and pi electron rule if it is, this is anti-aromatic. If you can take, suppose these two are like this direction, what will be happen in another one format? So like this will be happening. If towards this side, plus and minus. This ring system is what will happen? anti-aromatic 4 and 5 electrons. This one is 2 pi electrons, which is aromatic. One is anti-aromatic, one ring, another one is aromatic. So the overall system, while we get these two, but the overall system is non-aromatic. Non-aromatic. While we have to consider this non-aromatic. Suppose the pentylene, pentaphenolane, not pentylene, pentaphenolane system. This one also similar like this. If you go for this, what will happen? One is anti-aromatic. This is anti-aromatic. If you go for this ring system is aromatic. 4 and plus 2 pi electron rule is satisfied. 6 pi electrons are there. One is anti-aromatic, another one is aromatic. Overall, each one it may be there. So non-aromatic. So if you can similar, if towards this side also same thing. Heptafluorine also same ring system will be there. Trifluorine. This is trifluorine. Pentafluorine, heptafluorine, similar like this. Or else if it is, suppose one is tri, 3-membered, another one is suppose 7-membered ring system. If it is like this, will be there. This is not the following system. Calcium subsystems will be there. So here it is. Suppose if it is going to be aromatic, what will be happen? So if it is towards this side, it is anti-aromatic. This is aromatic. Towards this side, this is anti-aromatic. This is aromatic. So overall, this is non-aromatic. Overall, this is non-aromatic. Suppose if it is 5-membered, one is 5-membered, another one is 7-membered. What will happen if it is going to be this direction? It is anti-aromatic. This is also anti-aromatic. If it is going to be this direction, 6 pi electrons. This is aromatic. This is also aromatic. Tropylium cation will be there. Right? So this type of systems will be there. Aromatic and anti-aromatic. Another one is the allotropes of the carbon. And you can see the allotropes of carbon. Allotropes of carbons are diamond, graphite, and fullerenes. The diamond will be having sp3 hydrocarbon will be there, sp3 carbon. And it is sp3 carbon will be there, that is having carbon allotropes. Allotropes of carbon. The allotropes of carbon. While we can see this diamond. Another one which is graphite will be taken. Another one suppose which is having aromaticity can be decided by the fullerenes. So this is diamond which is having sp3 carbon will be there. So sp3 it may be there, what will happen automatically? This is having non-aromatic compound. Non-aromatic. The graphite will be having all our sp2 carbons will be there. sp hybridized carbons and planar the graphite system will be having aromatic, and which is having addition reactions are participated. Addition reactions are possible, and fullerenes also which is having aromatic. So here it is also addition reactions are possible. C60 fullerene, C70, C76, C80, 84, C86, 260. All are aromatic. All these are having aromatic. All these are having aromatic, which is having highly symmetric. These all fullerene systems are highly symmetric. Saccharines, buckyball type structures will be there, right? Highly symmetric. These are highly symmetric. In these systems, 12 pentagonal surfaces and 20 hexagonal surfaces are there. The systems which is having 12 pentagonal, 20 hexagonal surfaces are, this is highly symmetric, which is there. Highly symmetric. Right. Another one which is having the meso-ionic compound, another one meso-ionic compound, the first meso-ionic compound which is having aromatic. The first meso-ionic compound which is having aromatic, that one is sidons. Right, which is having structure like this. O minus like this. So if it is lone pair of electrons towards this plus and this H plus is losing X plus double bond which is there, and further it is turns to aromatic N plus C double bond C NO O minus. Here it is also lone pair of electrons will be there. So this one is having aromatic. 6 pi electrons will be there. That is having aromatic. This is meso-ionic compound which is having aromatic. This meso-ionic compound which is having aromatic. This is sidons. Right? If you can see the diionization of squaric acid diionization which is having aromatic. Diionization of the squaric acid aromatic. How it is aromatic? So towards this diionization of squaric acid, O minus plus O minus plus O minus O minus. All are sp2. So 2 pi electrons will be there. That means n value if it is 0, 4n plus 2 pi electron system is follows. 2 pi electrons will be there. This is having aromatic. This is having aromatic. Next another one more is, next one is the annihilation effect. What is the annihilation effect? The annihilation effect is each ring in the fused system, contributes part of its aromaticity to the adjacent ring. Contributes part of its aromaticity to the adjacent ring. That effect which is called as the annihilation effect. That effect is called as the annihilation effect. If you can see the benzene, and here it is minus will be there. So you can take this double bond. This is having aromatic independently. So if you can take this, this is also having aromatic independently. Right? Part of its double bond contribute this one and this one. Right? So this is having annihilation effect. This is the fused ring systems which is given. Fused ring systems. Suppose another one case. Suppose independently this is aromatic, this is aromatic, this is also. This is part of a contribution towards this ring, this ring. This is going to this ring, this ring. Annihilation effect. Right? If you can take another one also, another one more annihilation effect will be there. Another one more ring. So another one which is having, this is an annihilation effect. Number of benzene rings are increasing, number of benzene rings are increasing, part of its aromaticity, these benzene rings are increasing, so with respect to that per benzene ring, aromaticity is decreases. Aromaticity is decreases with respect to per benzene ring. So simple benzene, if it is resonance energy is 36. Naphthalene, if it is takes place 59. Anthracene, if it is takes place 71 something, it may be there. Anthracene. For benzene ring, benzene case, it may be 36 resonance energy will be there. For the naphthalene case, total overall resonance energy is 59. For benzene ring, 29 point something will be there, 29.5. And here it is case 23.6 something will be there for benzene ring in the case of anthracene. So the aromaticity with respect to per benzene ring, benzene is more than naphthalene than anthracene. So like this, right? Number of benzene rings are increases, with respect to per benzene ring, resonance energy is decreases, then aromaticity also decreases per benzene ring. If you take this chromosine, ferrocene, if it is, ferrocene is the aromatic, ferrocene, OMC, it is an aromatic, OMC will be there, aromatic, and chromosine, chromium, benzene ring will be there. Chromosine is also an aromatic, OMC will be there. Ferrocene and chromosine. Ferrocene and chromosine, which is having aromatic. OMC will be there. Right?